Okay, welcome back everyone. So we're going to have a go at this binary addition question. In this question it has told us that there are 6 bits for the mantissa and 4 bits for the exponent. Now we just need to be careful with this one because it hasn't done the separation between mantissa and exponent, so we have to work that out ourselves. So it's 4 bits for both of them. So what I would do is I would just draw a line just between those, so separating this into our mantissa and this is our exponent. Once we've got those values, we can then actually work out what the exponent is and then begin to add these values together. So the first step, let's just do this first value, is 0, 1, 1, 0. Again, our number line, 1, 2, 4, negative 8. So 4 plus 2 is equal to 6. And we do the exact same for this number as well. So 0, 1, 0, 0 is obviously 4. Now again, just working out that the exponents are 6 and 4 is a mark, so you've done the first step already. We then need to move the decimal points within these mantissas to the correct positions. So again, I would just rewrite what those numbers are. So the first one as so, and then the second number. And again, the rule with any floating point number, we're always starting our decimal points between the first 2 digits. And then we're going to move it based on what this exponent is. These are positive values, so we're going to move it to the right. So 6 spaces to the right for the first. So 1, 2, 3, 4, 5, 6. And again, we've run out of space, as we sometimes do with these floating point numbers. All we need to do is pad that with an extra 0. We'll do the same here for the second value. Again, positive 4. So moving it 1, 2, 3, 4 spaces to the right. Now at this point we just need to align these numbers. These decimal points aren't in the same position, okay, but it's a very easy fix in order to do that. So if we just consider what is to the left and to the right of each decimal number, that gives us a position where we can actually start to line these numbers up. So we're going to take this first value and we'll just put a decimal point here. So to the left of it, we've got 1, 2, 3, 4 zeros, 2 1s, and a 0. And then to the left of this decimal point, we've got 0, 1, 0, 1, 0. So 0, 1, 0, 1, and 0. So I still have the same values. Essentially, all I've done is I've shifted the numbers over to align these decimal points. Okay, and again, I've got some empty spaces at the start here. I can just chuck some zeros. Okay, it makes no difference. I've just moved this number 2 spaces over. Once I've done that process, I can then begin my binary addition. So 0 plus 0 is obviously 0. 0 plus 1 is 1. 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 0 is 1. And 0 plus 0 is 0. Nice and easy, no carries that time. Now, in order to actually get the correct answer, I do have my 6 bits mantissa, 1, 2, 3, 4, 5, 6. I have 7. Okay, we'll sort that in just a sec. Decimal point's going to start at the first 2 digits, and I need to get it over to this position over here. So that's a exponent of 1, 2, 3, 4, 5, 6. So I've aligned it with this exponent, okay? I've shifted this value, so therefore this is the exponent that has stayed the same. Now, the answer, needs to be in the same format, okay? So I do have 1, 2, 3, 4, 5, 6, 7 bits for the mantissa. So what I can do is essentially just get rid of this 0. It makes no difference on the actual value, so I can rewrite this number as 6-bit mantissa, leave a space just to show you now working on the exponent. Okay, and as we said, that's going to remain as this original value. So this is my exponent, and this is mantissa. Okay, and this is your final answer, 6-bit and 4-bit.